Grade 11. Today I'm going to make a video related to a limited reagent and theoretical yield. Now, note the following. In order for you to identify the theoretical yield, you must know in a chemical reaction what substance is the limiting reagent. Otherwise, you won't be able to calculate the theoretical yield because they are related one to another. So before we go further, then let's let's see what is the definition of limiting reagent. Now, what is the limiting reagent? Limiting reagent is the reactant that will finish first in a chemical reaction. So it's the reactant that finish first during a chemical reaction. During a chemical reaction. So you have in the chemical reaction different substances. For example, here we have that in the reactant we have sulfuric acid and we have ammonia. Whoever finished before in this reaction will be the limiting reagent, and whoever finished after will be the excess reagent. Okay, so in order for us to be able to obtain the theoretical yield, then we have to identify the limiting reagent. We must know what substance is going to finish first, and that one will give us the theoretical yield. Okay, so now how we can identify the limiting reagent. Let's first go to the question. This is one example that will help us to find out the limiting reagent. The sulfuric acid reacts with ammonia to produce the fertilizer ammonium sulfate according to the following equation. And then you have the equation here. Okay, they say what is the maximum mass of ammonium sulfate that can be obtained. This maximum mass of ammonium sulfate that can be obtained is what we call theoretical yield. Theoretical yield. That is the theoretical yield. How much of ammonium sulfate can we form from this chemical reaction? Now, in order for us to know that, we need the limiting reagent, because that one is the one that is going to give us how much of this one will be formed. Okay, so what is the maximum mass of ammonium sulfate that can be obtained from 2 kilograms of sulfuric acid and 1 kilogram of ammonia? Now, they're giving us the total amount of sulfuric acid and the total amount of ammonia that they started with. One of them might finish first, we don't know, but one of them might finish first. So we have to identify which one is going to finish first. Now, the first step is going to be, say, step one. Step one, we're going to calculate the number of moles of each reactant. In this case, we have sulfuric acid and we have ammonia. All right? So remember, the formula to calculate the number of mole, there are many, but this is one of them. Number of mole is equal to mass divided by molar mass. All right? Now, what is the mass of a sulfuric acid, the one that they started with? The total mass, that was 2 kilograms. Remember, you cannot work with kilograms, not here. Therefore, this will be equal to 2000 grams. And now the molar mass of a sulfuric acid, let's go back here and say sulfuric acid, is H2SO4. Now, the molar mass of sulfuric acid, we have to get the relative atomic mass of each of the elements that form the sulfuric acid. So we have to get the molar mass of each of them. So for example, we have 2 hydrogen, we have 1 sulfur, and we have 4 oxygen. So this will be 2 times the mass of hydrogen. Let's go to the periodic table, which I have here. Hydrogen is 1, comma 0, 1. We're going to work with 1, okay? With 1. 2 times 1 plus 1 sulfur, and sulfur is here 32,1. You must remember to use the periodic table you have with you. You don't have to learn those values by memory. It's 32,1 plus oxygen. You have 4 oxygen, so it's 4 times oxygen. And if you go to oxygen in the periodic table, you have 16. There is oxygen times 16. Okay, so let's do this calculation in the calculator. 2 times 1 is 2 plus 32,1, so it's 2 plus 32,1 plus 4 times 16. Let me just show you. 4 times 16 plus 4 times 16, and you have to open bracket, 4 times 16, and the answer is 98,1. This is 8,1 mole. Okay, 98,1 grams per mole. It's not mole, it's grams per mole. That is the unit for the molar mass. So let's continue and calculate the number of mole. Number of mole is equal to 2000 divided by 98,1. So it's 2000 divided by 98,1. The answer is 20,39. Okay, 20,39 mole. And now we have to do the same. This is for H2SO4. We have to do the same for ammonia, NH3. Okay, the number of mole is going to be equal to mass divided by molar mass. The mass of ammonia is, before we go on, the mass of ammonia, the mass that they used here was 1 kilograms. So let's just get that conversion. This is 1 kilograms, which is equal to 1000 grams. And the molar mass for ammonia, here, ammonia, remember, is NH3. We have 1 nitrogen and 3 hydrogen. So let's just calculate the molar mass for ammonia. Now, nitrogen. What is the molar mass for nitrogen? You go here, it is 14. So 14 plus 3 times 1 comma, what we used here? 1. We use 1. So let's continue with 1 for hydrogen times 1. Okay? Now 3 times 1 is 3 plus 14 is equal to 17 grams per mole. Right? So now we can calculate the number of mole of ammonia. Number of mole is equal to 1000 divided by 17. 1000 divided by 17. Let's go to the calculator. 1000 divided by 17, and that gives me 58,82. 58,82 mole. So we have now the number of mole of the two reactants. Now, note the following. The fact that the number of mole of sulfuric acid is less does not mean that it's going to be the limiting reagent. So it does not mean that you have now less moles of sulfuric acid is going to be the limiting reagent. Okay? So now we have to go to step 2. We have to go to step 2. Step 2. Now in step 2, we're going to use the ratios of the reactants to product, we're going to use the ratios of reactants to products to determine the limiting reagent, or who will finish first. Determine the limiting reagent. Okay? Now, reagent. Now, how we do that? We're going to check the ratios between each reactant with the product. So, for example, we're going to check first the ratios between sulfuric acid and ammonium sulfate. Okay? So let's come here and say, in this case, we're going to say sulfuric acid is H2SO4 to the reactant, which is ammonium sulfate, and H4 to SO4. So we're going to check this one. Let's move it a little bit to the side. Let's move it here, and then here I want to see the ratio of let me just check the ratio on the side of the other is ammonia to ammonium sulfate. Okay, now if you go back here, the ratio of sulfuric acid to ammonium sulfate is 1:1. Remember, the ratios are given for the numbers at the front. So this is 1, this is 2, this is 1. Those are the ratios, the number at the front. So here you can see that for sulfuric acid and ammonium sulfate, the ratio is 1:1. Ratio is 1:1. What does it mean? It means that if you use 20,39 mole of sulfuric acid, 20,39 mole of sulfuric acid, you will get 20,39 mole of ammonium sulfate. Do you understand? I'm going to go back. The ratio is 1:1 for sulfuric acid and ammonium sulfate. So if you use, for every 1 amount of sulfuric acid you use, you will get the same amount of ammonium sulfate. So if you use 20,39 mole of sulfuric acid, you will also get 20,39 mole of ammonium sulfate. Right? Now let's do the same for ammonia. Now for ammonia, the ratio is 1:2. You can see here, or 2:1. Sorry, 2 of ammonia. 2:1. So for every 2 amount, or for every 2 quantities of ammonia you use, you will only produce half of that amount of ammonium sulfate. So for example, when you use here 58,82, you will only get 58,82 divided by 2 because it's half. You will only get half that amount, which is, let's use the calculator, 58,82 divided by 2, that is equal to 29,41. 29,41 mole. All right? Let me move it a little bit here. 29,41. Right? So, using the amounts of grams that we started at the beginning, this is what we get of the product. If we use 20,39, we get 20,39. If we use 58,82, we get 29,41. So which one will give us less amount? Which one will give us less amount? Okay, first you can see clear that will be the ammonia. This one is less than 29,41. So sulfuric acid, therefore, is going to be the limiting reagent. H2SO4 is going to be the limiting reagent. H2SO4 is the limiting reagent. It will finish first, okay, because it gives you less amount of the product. All right. Now, step 3, which will be to find out or to calculate the theoretical yield. For the theoretical yield, we have to use the number of mole that we get in the product according to the limiting reagent. Okay, so let's go to step 3. Now, step 3 will be calculate the limiting. No, sorry, no limiting. We already determined the limiting reagent. What am I writing here? Calculate the theoretical yield. Calculate the theoretical yield. Now, to calculate the theoretical yield, we need to find out the limiting reagent, which we did. Okay? Now, the theoretical yield is the amount, in theory, how much grams of the product we can get. That is theoretical, it's not realistic. It's in calculation, how much we can get. It does not mean that we are going to get that in real life. Okay? So, now to get that one, we have to calculate the mass of the product, which is equal to number of mole multiplied by molar mass. All right? So, the number of mole. What is the number of mole that we are going to use? We are going to use the number of mole that we get with the theoretical yield. That is the number of mole we're going to use here. So, it's 20,39. So, the number of mole is 20, let me write it here, 39 mole. Now, for the molar mass, let's get the molar mass. So, let's write here what we have, ammonium sulfate. So, let's write here ammonium sulfate. Let me just write it down first. This is ammonium sulfate, NH4 bracket 2SO4. All right, so how do we calculate the mass here? We have this bracket, so it's 2 of everything. So I'm going to write 2, and I'm going to open bracket. The mass of nitrogen in the periodic table, it is 14. Here it is, right? It is 14. So 14 plus 4 of hydrogen, which is 1, plus sulfur. Remember sulfur, we already look at sulfur. It is 32,1. Plus 4 of oxygen, which is 16. All right, and this is how to calculate the molar mass of ammonium sulfate. Right, now you can use your calculator. I'm not going to be doing the whole calculation. This is equal to 132,1 grams per mole. And now we can substitute this one there. So the mass is equal to the number of mole, which is 20,39, multiplied by the molar mass, which is 132,1. So let's calculate 20,39. 20,39 times 132. That gives me 2,691. 2,391. Sorry. 2,391. 2,691.48 grams. This is the theoretical yield. That is the answer for the question. You can, if you want, convert it into kilogram because the initial question is in kilogram, but it's not needed. All right? So this is, in theory, what we can actually get from the equation. This is the final answer for the question. Okay? Now, next time, in the next video, we are going to learn how to calculate the percentage yield. And we are going to use the very much same example. Thank you very much. I hope you understand. It is important. Without this identification of limited reagent, you cannot get to the next video, which is the percentage yield. Thank you very much.